Welcome friends. So in our upcoming videos, in the video training, we will learn about the primary impedance, secondary impedance, or it's also called as seen impedance or reflected impedance, and the transformation ratio. So what's meaning by these? I will give you a brief idea, then we will discuss these things in detail. So let's go to our next slide. So here you can see this is a transmission line, and we have shown the impedance of the transmission line in ohms. So the primary impedance of the transmission line is 0.2376 ohms. Okay, so this impedance, that's the impedance of the transmission line itself, is called as a primary impedance. So this is the primary impedance. What does it mean by the primary impedance? For example, if you have a transmission line, okay, we have three conductors, for example. If you connect an ohm meter and calculate the resistance R, for example, and also you measure the reactance Jx. So in short, using the equipment, you are measuring the impedance of the line directly using some secondary equipments. So you are measuring the R, X, and ultimately Z by using the measuring equipment. Then this impedance, this resistance, reactance of the line is a real reactance of the line, is called as primary reactance. So this is the actual reactance of the transmission line. So we call it as a primary value. Why we are calling it a primary value? Because this is the values of R and X are the real values. Similarly, here you can see that the primary value is shown in ohms for the transmission line, and this is 0.023276 ohms is the primary value of transmission line. Whereas, do the relay see the same impedance? Because relay is also getting voltage and current. Do the relay also sees the same impedance or not? So answer is the relay is not seeing the same impedance. So here you can see this is the value of impedance that is seen by the relay, which is Z seen by the relay is 0.46552. Okay, so actual value of impedance is 0.23276, and the impedance that's seen by the relay is 0.46552. So when you will come to the relay, if you see what is the impedance, this is the impedance will be shown or at the relay itself. So the relay actual impedance is called as a primary impedance, primary value, and the impedance seen by the relay is called as a secondary impedance or secondary value. And there is a difference between these two. I will tell you what is the reason behind that. So, for example, if primary side voltage is 110 kV and we have VT ratio installed 110 kV by, for example, 100 volts, okay, so the voltage seen by the relay, if at the primary voltage is 110 kV, if you will call this is as a primary value, then the secondary value of the VT will be 100 volts, and this secondary value is basically the value that's seen by the relay. So you can see there is a difference of voltage already from primary to secondary, from 110 kV to 100 volts. And for example, current at the primary side is 1000 amperes, okay, and we have CT ratio 2000 by 1, okay. Then you can see the current at the secondary side will be 0.5, and you can see this is the value of ohms that will be seen by the relay, and the primary ohms are equal to here you can see 110 kV divided by 1000 amps. So here you can see the value seen by the actual value of impedance is this, whereas the impedance that's seen by the relay is this much. Okay, so both have the differences, and the difference is caused by the two instrument transformers. One is a current transformer, another one is a voltage transformer. So they are transforming the voltage with different ratios. These are not 1:1 transformers. So if these are the 1:1 transformers, then the primary and the secondary would have been the same values. But these are basically the instrument transformer with some different ratios. So if you want to find out the secondary value of impedance, then you need to multiply primary impedance by the CT ratio divided by the VT ratio. So then in this way you can calculate directly the reflected or secondary impedance if you know the primary impedance. So this factor, current ratio, CT ratio by VT ratio, this factor is called as transformation ratio. We are using this factor, transformation ratio. We are using this factor in our calculation to reflect the primary impedance to the secondary side, because we are doing most of the time calculations of impedance or zone settings in secondary values. Okay, so this is an example. This is a basic thing that you need to understand. In next section we will go in one by one in more details, that how I will show you in calculation as well, where I will do the calculations of the primary and secondary impedances, and I will show you how the conversion factor is basically working. So just keep watching and keep learning. Thank you very much.